Assalamu alaikum wa rahmatullahi wa barakatuh. Our subject today is about concept and investigations of epidemics. What do we mean by that? What is epidemic? Epidemic definition is the occurrence of an illness in a community or region with a clear excess of normal expectancy. There is an increase in the number, in the amount, beyond the expected number. And the cases are related to each other, and they are derived from a common or propagated source. So the occurrence of certain disease in a huge number in amount, more than expected for that disease in certain area, and also it is related to each other, and they are derived from a common or a propagated source. Or other alternative definition, it is defined as substantial increase in incidence rate of certain disease in a specified population or region over specified period of time. So the term excess mean the public health emergency. When it is a public health emergency, it needs urgent action, as in case of corona. For example, we have a single case of smallpox anywhere in the world. It is considered as an epidemic because the normal expectancy of a smallpox in the world is 0. So what causes epidemics? Either there is introduction of a new disease agent into a susceptible population, like coronavirus, or if there is change or deterioration of the environmental condition that facilitate disease agent transmission and reactivation of already existing agent. And other third factor is change in population immunity and an increased susceptible pool, or maybe any combination of the above, first and second and third, or all together. So any combination of the above factors. The study and control of epidemics is useful because why it is important to study epidemics? Why it is important to control epidemics? Because it contributes to the betterment of individual health, to improve any patient health, and also to protect the public health, not only personal or individual health, but also the public health. And it is useful for research. And this represents a unique package of person, place, and time. So we have to study epidemics and to maintain control and to have useful research to be applied later on when it is needed. The dynamics of epidemics. 2 factors determine the shape of an epidemic pattern. First of all, the relative frequency of the incubation period of repeated cases. This is important. And the second is the duration of exposure to the source of infection. So we call it the epidemic curve. We have to study the epidemic curve, which shows the frequency of new cases over time. This based on a date of onset of disease. Also, the shape of the curve is important in relation to the incubation period for a particular disease, can give a clue about the source. So, epidemic curve is important because it gives us the frequency of the new cases, and the shape also is important to have the relation to the shape to the incubation period. And there are 3 basic types. First of all, we call it the common source. We have to follow types of epidemics. Common source, which is either it is point source or extended or propagated. What do you mean by point source? Point source, the exposure to a single source of disease. This exposure is brief and simultaneous, and all the resulted cases develop within one incubation period. For example, incubation period of hepatitis A extends from 5 to 30 days. So all the exposure, all the cases will appear within this 30 days. This is what we call the point source. Extended source, the exposure is also to a single source, but it extends for a long time, and result cases continue to appear beyond one incubation period. So the case starts from a simple or single source, and then it extends beyond one incubation period, while in point source is within the incubation period, within one, not extend beyond. And the propagated source epidemic, in this type we have serial transmission of cases that continue to take place until the pool exhausted or control occur. We will talk now about the point source outbreak. call it point source epidemic. It involves a common source such as contaminated food or infected food handler, like in typhoid food handler. We call it Mary. Mary was a cooker for the army, and it causes spread of a lot of cases, spread of typhoid fever in a lot of cases in the army. And here the exposure tend to occur in a relatively brief period. And consequently, point source outbreak tend to have epidemic curve with a rapid increase in cases followed by a somewhat slower decline. So the outbreak here occur in a rapid increase and then decline, but the decline is slower. And all the cases tend to fall within the incubation period, as we said, rapid increase and a slow decline within the single incubation period. So we have an example for hepatitis. There is a graph of hepatitis A outbreak is an example of a point source epidemic. The incubation period for hepatitis from 15 to 50 days with an average of about 28 to 30 days. In a point source epidemic of hepatitis A, you will expect the rise and the fall of new cases to occur within about 30 days span of time, which is what is seen in the graph below. So this is the graph. As we said, it started from 25th of April to 25th of May. And here we have these are the space between a case and another, and this is the incubation period, and there is spread. But the incubation period within 1 month, all the cases appear within this period, within 1 month, although there are different dating between case and another. This is a group of case, and this is another group, and here it is the peak cases. So they arises in different time between the period of 1 month. This is what we call point source. We have one source, and the cases, although they are rising and they start to decline, but this occur, the rising and decline within the same period, incubation period I mean. So the continuous common source epidemic, they may also arise to peak and fall, but the cases do not all occur within a span of a single incubation period. This implies that there is an ongoing source of contamination. It is not only a single case, there are multiple cases. The down slope of the curve may be very sharp if the common source either removed, or maybe it is gradual if the outbreak is exhausted by itself. So we have incubation period. It is there is ongoing contamination, but the incubation period or the period of infection, it is extend beyond the single incubation period. As in cases of hepatitis, as we said, it is started to have the infection here among this incubation period between 28 to 30 days. Once it is extend about this period, we suspect of other source of infection. We call it the continuous common source. The epidemic curve below is for cholera outbreak in a Broad Street area in London in 1854, and that was investigated by Dr. John Snow. The cholera has an incubation period of 1 to 3 days, and even though residents began to flee, to run away when the outbreak erupted, you can see that this outbreak lasted for more than a single incubation period, as we said, and this suggests an ongoing source of infection. In this case, the Broad Street pump. Here, as you see, this is the period from August till September. This is a case of cholera, although its incubation period is 1 to 3 days, but it is start to occur here in a few cases appear on day 19 of August, and other few cases then arises on the days before or the days after, but there is a rapid rise on day 31, and with the beginning of September there is a huge rise, and then it starts to decline. But the incubation period here is more than beyond single incubation period, and they are close together. This is one crust, one rise, but they are close, matted together. And then there is a period of declining, and then till they disappear. This is an example of continuous common source. We have a propagated or progressive source epidemic. An epidemic curve from an outbreak of measles that began with a single index case who infected a number of other individuals. Incubation period of measles ranging average 10 days, a range from 7 to 18 days. One of or more of people infected in the initial wave infected a group of people who become a second wave of infection. So why we call it propagated or progressive? Because there are different waves, and the first wave there is someone who infect others, and then in the second wave those who are infected in the initial wave infect another group in the second wave. So here transmission is what we call person to person rather than from a common source. Person to person transmission in the propagated type of epidemic. Propagated epidemic curve usually have a series of successfully larger peaks. There are larger and larger peaks, which are common incubation, which are one incubation period apart. They are separated from each other. These peaks are separated from each other by one incubation period apart. And the successive waves tend to involve more and more people until the pool of susceptible people is exhausted or control measures implemented. This is an ideal example. However, in reality, most of these epidemics do not produce classic pattern, so it is an ideal wave curve. So as we said, this is a propagated or progressive source of epidemics. So we have here from March, there is case index appeared, and from the 4th of April it start, and there is cluster or peaks, number 1, peak number 2, and peak number 3. And these peaks, there is an area, or we called separated by the incubation period time. There are clusters, they are separated by a period of incubation period, and also the peaks are larger. There is successfully larger peaks. The first one is smaller and the second is larger, and then it start to decline. When it decline, when the control measure is start, or when the susceptible people exhausted. So other relevant concept regarding epidemics, we know it as outbreak. Outbreak is the same as epidemic. An acute short epidemic such as an outbreak of food poisoning. We have pandemic, we have endemic. What are the difference? Outbreak is epidemic. As we said, it is an acute short epidemic such as an outbreak of food poisoning, while pandemic, it is involved more than one country, like bird flu, SARS, tuberculosis. And endemic is the constant presence of a disease, or it is causative agent in defined geographical area. So this is endemic. It is present and it is constant. Its presence is constant in certain area in the world, in certain geographical region. While epidemic, as we said, there is sudden, acute, and short outbreak. And here, pandemic, there is, as we said, more than one country is affected. More than maybe not only the country, but continent. So it is spread all over the world. An endemic disease may show epidemic wave every now and then. So as we said, there is endemic here in our country, in Amara city, endemic in TB and typhoid fever. So every now and then there is increasing number, and we call it epidemics. Every 3 to 4 years, epidemics of typhoid, epidemics of TB, and occurs every 3 to 4 years. Of course, immunization against measles modified very much pattern. Investigation of epidemics. First of all, we have to remember that there are steps to investigate. There are 10 steps. Verification of diagnosis. We have to diagnose a case and confirm the existence of an epidemics. There are a lot of cases appear at the same time, although different type, maybe point source, or as we said, excessive or increasing or propagating, and so on. Different type of curve, epidemiological curve, and usually we need to define the population at risk. Like measles affect those who are less than 5 years, while hepatitis mainly 2 groups, in children and older patient. Rapid search for all cases and their characteristic, the sex, the age, the occupation, water drinking, and so on. These help to find the source. And data analysis, we have to collect data and to analyze these data and to get more information, help in searching the cause and to control the disease. Formulation of hypothesis and then testing the hypothesis, and evaluation of ecological factors, and further investigation of population at risk, and writing report. Verification of diagnosis. How we verify? It is important to make sure that the case under investigation are definite case of that disease. And this is done by careful history, physical examination, and relevant laboratory investigation. For example, blood culture in typhoid fever is very reliable diagnostic method. Never depend on the clinical sign and symptom or serological study. We have to depend in this case in typhoid fever on blood culture, which is definitive diagnosis. Number 2 is confirmation of the existence of epidemics, which means there is excess case above normal expectancy. Is this real? There is excess case? This is ascertained by comparing the reported cases at the time of epidemic with the cases reported in previous months or years. So is there any really increasing number of cases and different from this year and the year before? Number 3, identification of the affected cases and their characteristic. This is important because it may help to identify a common experience or exposure of cases, and thus to facilitate the identification of the source. So we have to know the sign and symptom, and we have to identify the experience, how to diagnose a case here. As in coronavirus, these are the signs and symptoms. There is fever, cough, shortness of breath, sore throat, headache, and in addition, there is abnormal CT finding in the chest. So we can identify easily the source of epidemics, and we have to identify in what area it started, which area. So number 4, further investigation of population at risk. In coronavirus, it affects mainly elderly patients. It affects all age group, but it is more harmful and fatal in elderly patients. And we have to search for further investigation for population at risk. Mainly those should be investigated, and also the contacts or carriers and of hidden cases. Usually children in coronavirus, the young age group, they have less sign and symptom. Children are mainly asymptomatic, but can they carry the disease to others or not? So we have to investigate all these. Now, the study of environment is important to identify factors which likely correlated to the epidemics. For example, we have to search for any change in the environment or immediately before the onset, at onset or immediately before the onset. So as in coronavirus, some said that high temperature will stop the spreading of this coronavirus, but actually it is not. So they have to study the environment and to find the relation or correlation between the spread of infection and the environmental factors. Number 6 is formulation of hypotheses about the epidemic regarding source of infection, mode of transmission, existence of reservoir of infection and carrier. So this is the hypothesis. They said this is infection, there is a cycle of infection, it is spread, the man is here reservoir, and there is a port of access, and maybe contact, close contact cause a mode of transmission, and then it will enter to other susceptible hosts. So this is infectious chain or cycle, and then once there is an infection in one person, and he will transmit the infection to others. And so this is number 2, case identification and contact tracing. This is contact tracing. And then lastly, isolation to prevent additional spread. So we have to put a hypothesis. Is it contagious, and the way of spread? Is it from person to person, or how to stop the spread? Management of epidemics. This includes treatment of cases and carrier should be treated, both of them. Protection of high risk and susceptible person by immunization if it is available, and by chemotherapy also if it is available. And then writing report about epidemics, and continuous surveillance to prevent further epidemics. It is important, continue surveillance. And this is important to prevent future epidemics. Experimental verification of agent of the disease and mode of transmission to be sure that this is the agent, and we have to do experiments to show if it is really infectious and causes a disease. Once we isolate the agent and the type of transmission, whether it is a droplet or through blood or secretion or anything. So it is an experimental event. Now we have definition of the basic term related to epidemiology of communicable disease. What's infection? Infection of man or animal is the entry and development or multiplication of an infectious agent in the body. What's the definition of infectious disease? Is a disease of man or animal result from infection. And what's communicable disease? Is an illness due to specific infectious agent, or it is toxic product which developed through transmission, or that agent or it is toxic product from reservoir to susceptible host, either directly or indirectly. So these are simple definitions. What is reservoir? An human being, animal, plants, arthropod, soil, inanimate matter, in which an infectious agent normally lives and multiplies, and from which it passes to a new host. This is definition of reservoir. Susceptible, a person or animal having no resistance against pathogen, any pathogenic agent, and to prevent disease. What is carrier? Carrier, an infected person who harbor a specific infectious agent in the absence of a clinical feature. It acts as a source of infection to others. And there are three types of carrier, and the three types may be incubatory carrier, or convalescent carrier, or a chronic carrier. So what do you mean by incubation period? Now the time interval from infection, mean exposure, till the appearance of the clinical features of infectious disease. And this is used for infectious and non-infectious diseases, not only infectious incubation period, infectious and the non-infectious. It is very useful in retrospective tracing the source of infection. As we said, we depend on the incubation period and we have to know the source. And in following up contacts to determine whether they are infected or not. Mode of transmission, the way the disease agent are transmitted from source of infection to a new. And the common mode of transmission are either direct or indirect contact. Direct contact or direct transmission, we have direct contact as here in rabies, or droplet infection, or contaminated soil or water, or bite of animal, or by infected with the contaminated vomits of infected patient. Indirect means indirect transmission through a vehicle-borne or vector-borne or airborne. And other routes like injection, transplacental, laboratory infection, these are different type of transmission. What we mean by chemo prophylaxis is the administration of a chemical, including antibiotics, to prevent the development of an infection, or at least the progression of infection to the active infection disease. Like, for example, in patient with TB, they need chemo prophylaxis, either to stop the disease or to stop the propagation and progression of that disease. Example, chloroquine for malaria, INH for TB. And we have chemotherapy, the use of chemical to cure clinically recognizable disease or to limit its further progression. How we prevent? The prevention is to take the occurrence of something like disease or accident, make it impossible. Is how to make that thing impossible. Prevention can be a practice as the three level: primary prevention, secondary and tertiary prevention. The general strategies to control communicable disease is, first of all, by the elimination of the source of infection by effective detection and the treatment of case and carrier or any other source. So elimination of the source is number one. Number two is interruption of the transmission pathway by either by destruction of the intermediate host, or destruction of a breeding site and purification of water. Third is improvement of the host resistance or immunity against infection, like immunization, and maybe combination of all methods. Thank you.